And then in the next session, which we will preview, we'll be creating some visualizations and adding interactivity. So we have a fun couple of days ahead of us to wrap up the course. First, to spread out the forking of the follow along notebook, I would like to ask that folks, where if it's morning for you, if it's around morning, go ahead and fork that notebook now. And then we'll just spread that out a little bit over the introduction. So you should see the link to that follow along notebook will be added to the chat. All right, so today what we're going to do is we are going to do a little recap and warm up, because I know even if it's only been 5 days since the last time we met, it's easy to get some rust building up pretty quickly, especially when you're learning something new. So I'll do a little recap and warm up activity. Then we're going to hop right into new stuff, which will be finding descriptive statistics like means and medians and counts of things and sums using methods from D3. And then we're going to move on to do that by group. So instead of for a single array, be able to identify groups within a property or a variable and then find summary statistics by group. If it is afternoon for you now or around afternoon, go ahead and fork the follow along notebook. So hopefully that can be shared. So go ahead and fork the follow along notebook that was shared. Okay. And we're also today going to be visualizing summary values in Observable Plot. So we'll see how we can do some grouping even within Plot, so you don't even have to do it outside of it all the time. All right, so if it is evening now, if you can go ahead and fork the notebook, then hopefully folks will be able to fork. As a reminder, if you just press fork one time, it might take a few seconds to actually create your copy. Just let it run. If it's grayed out, you don't need to refresh. So you can go ahead, press it once, let it run, and then you should see that your copy is created in your own account that you can follow along with. Okay, cool. So it looks like the notebook was shared and people are forking. Fantastic. All right. A couple of reminders is, as you have questions throughout the session today, you can drop them in the Slack here that you are looking at where these links have been posted. But you can also join, if you haven't already, our community Slack channel. There is a channel just for this course where you can also ask questions and follow up. It's been great to see people trying things and following up with their questions, even when we're not actually in the course. So we'll be excited to also see you there. And as a reminder, in case anybody needs to cut out early, the last session of this course is tomorrow, Thursday, from same time, 12 p.m. to 1 p.m. Pacific. So look forward to seeing many of you there too. All right, and anybody else now, if you didn't fall into one of the time zones that I referred to, or if you're just getting here, go ahead and fork that notebook so that we all have our own copy to work in. Okay, so we'll do a quick recap and warm-up activity before we get into today's new material, which is what did we do last week? Last week we covered a lot of fundamental things that we need to know in JavaScript. So we built a lot of building blocks that are pretty core to doing a lot of data wrangling and analysis. And that included learning about arrays and objects. We learned about arrow functions as a concise way to create functions in JavaScript. We learned about the map and filter methods, which will iterate through different elements of an array. Map will then apply a function and return the outcome of that function. Filter will check a condition and then return whatever objects actually satisfy that condition or return true. We also learned that there is a cool package or a library called Arcaro, which if you're used to working in dplyr or even pandas, Arcaro offers some familiar feeling verbs to do data wrangling. And we ended each day doing a little visualization with Observable Plot. So let's go ahead and get that rust off from last week with a little warm-up activity. So hopefully everybody is able to fork the notebook. If I go back, I'm going to switch back over to my notebook now. Again, this is an online data canvas where we can combine our text and our code and outputs all in the same place, along with other specialty cell types, some of which we'll see tomorrow. And we're going to start with activity 1 here. As a reminder, for each of the activities that we'll do in this notebook, there's this show me option. I recommend trying to follow along writing the code with me, but if at any point you get stuck, if you click that show me button, it will reveal the code that I'm writing and the expected results. And if you get stuck, you can go ahead and copy that, paste it into the JavaScript cell where we're doing the activity, and then you should be caught up with that one. All right, but what are we doing in this first activity? In this first activity, we are using a data set about penguins, especially relevant since it was World Penguin Day yesterday. So this is a data set that contains size measurements for 344 penguins measured in near the Palmer Archipelago in Antarctica from 2007 to 2009 by Kristen Gorman and her colleagues. And there's columns for like species, penguin species, the island they were recorded on, the body mass, the bill depth and length, and flipper length. So what we're going to do is we are going to go ahead and start creating code using map to go ahead and work with this penguin data. And yeah, I'm seeing some great penguins, some great penguins. I'm always seeing great penguins these days. But I've seen some good questions about like, how are you going to work with this data? So the penguins are one of the built-in data sets within Observable, so we have access to it. I'll go ahead and bring up here what that actually looks like. So I'll just show you a preview of what this looks like here. So this is the structure of the data. So we can see species, island, Coleman length and Coleman depth here. Those are other words for bill length and bill depth, and then flipper length and body mass and penguin sex. So our job for this warm-up activity is going to be using array map and array filter. And again, you could do all of these steps with verbs in our Caro too, but we're going to do it with map and filter. We are going to make a subset that has properties for species, mass converted to kilograms, and bill ratio, which is the ratio of bill length to bill depth. And then we're going to filter that subset to only keep penguins that have a bill ratio of greater than 3.5. So let's go ahead and do it. So in this cell, I'm going to start writing my code. I'll say I'm going to start with penguin data. Maybe I'll make this a little bit bigger. Hopefully that helps. So I'm going to start with penguin data, and then I'm going to use .map. Again, map's job is to iterate over each element in an array. In this case, we have an array of objects, so it's going to be iterating over all of the objects. And in this case, each of those objects contains information for a single penguin. Then I'm going to give it an arrow function to tell it what to do. So I'm going to say, given some input parameter D, which is going to be each of the objects that it's iterating over, I want to return a new object. And so to create that new object, and so that this isn't confused with some symbols that are used for a function, the curly braces, I'm going to do an outermost parentheses and an innermost curly braces. And within this curly braces is where I'm going to say, what should this new object contain? So we have a couple of things. We still want to have species. So I'm going to say, I want to have a key called species, and what that key contains, the value should contain whatever was already in the species property for each of these objects. So this is essentially like making a copy of the species property in this new subset that I'm creating. So that's the first one. Then we're asked to have a property that is called mass kilograms. So I'm going to write that, mass kilograms, again, using this camel case that you'll see so frequently in JavaScript. And what that's going to contain is that's going to have my penguin body mass, which is currently in grams, divided by 1,000 to convert it to kilograms. So I'm going to say access, and we access properties of an object using this object dot key name. So here I'm going to do d dot body mass grams, and that is going to get the value of body mass in grams for each penguin. And then I'll divide it by 1,000. And I could run this at any point, and we could see what we have so far. So if I run this code again with shift return or by pressing the blue triangle in that cell, then if I look at this array output, I can see here, yep, so far what it's returning is a new object where I just have species, but now I also have this mass kilograms property. That's my mass converted to kilograms. So let's keep going. The last thing that we're asked to do for deriving a new property is find the ratio of column length to column depth. So I'm going to call this a new property with a key bill ratio, and that is going to contain the value of column length millimeters divided by the value of column depth millimeters. And again, running this, I could look back. I usually look when I'm doing data wrangling. I usually look back to like see after every step what I've created to make sure it's doing what I expect it to do. So again, if I look at this array, now I'll see like, oh, yep, now I have this bill ratio, that ratio of bill length to bill depth for each of my penguins returned. So now I have done this first task, which is combines a lot of data wrangling steps in one place, right? Which is, I think, really nice about using map here, is that it's actually combining like a select, like selecting specific columns, in this case, properties. It's also doing a derive. So we're deriving new values based on existing columns. But you can also, within this, relocate things, use it to rename things. Like if I wanted species to be stored as species penguin, then I could just add that species penguin as the key here that gets returned. All right, so now we've done this first line, but next we want to filter this array to only keep objects where the bill ratio that we just created is greater than 3.5. So again, we'll just do chain right into this. So I'll do dot then filter to go ahead and then give it a condition. So here, this condition, I'm also going to use an arrow function. So I'm going to say, I want to check the condition, does bill ratio exceed 3.5? And once I do that, then it's going to filter to say, okay, apply this function. If this returns true, then I'm going to keep that object, which looks like rows in our array of objects. And if not, I'm going to exclude it. So if I run this, then I will see that the only penguins left are 3 big Gentoo penguins, and these are the ones that have the bill ratios greater than 3.5. All right, so hopefully that brings back some of the major things we learned about last week. We're using a map, we're using filter, dot chaining, objects, arrays, accessing values from objects. So this covers actually quite a bit of what we did last week in one place. Okay. Oh, cool. So I see some good questions and responses. Yeah, it's awesome to see people responding here. Okay. Okay, so I think Sharon's question was answered. Why do you have that extra parentheses? It's so that it doesn't get confused. And thanks, Jeff, for responding in the chat. So we have that extra parentheses here when we're creating that new object, so it's not confused with possibly creating a function. Great question. And then another question. Are parentheses outside brackets in map mandatory? So I think, and I might be wrong, so feel free to follow up, but I think you're asking if you have to have the parentheses out around the D here, the single parameter. And if it's just a single parameter, then no. But as soon as you started having like multi-parameter functions, basically anything besides a one parameter function, then you do have to have it contained within parentheses, which is why it's automated here with this pretty formatting. Good questions. All right. So I'm going to hop back over to the slides and let's get into our new stuff for today. Okay, so we're going to hop into, now that we have some wrangling skills, we're going to jump into descriptive statistics. So D3 is usually thought of as an amazing framework for creating totally customizable data visualizations that truly can do whatever you want. But it also has a bunch of methods and tools to allow you to work with data, including many that we'll use today to find descriptive statistics like means, medians, standard deviations, variance, counts, ranges, minimum and maximum, and more, way much more than are here. You can bin things, you can find quantiles of things. But we'll be exploring a few of these and looking for predictable patterns and how we could find these given the data that we have. All right, so I'm just going to show an example because we want to see like a predictable pattern in how these different methods can be applied to find these descriptive statistics. So here I'm showing the penguins data set that we're using throughout the day today. And we're going to use D3 mean first to find the mean of the entire body mass property in penguin data. And I'm calling these properties. If you've been working with data frames or spreadsheets, oftentimes we think of these as variables, but those align closely in our thinking here. So here, if I want to find the mean of the entire body mass column, so that entire property here, then the way that I can do that using D3 mean is I say use D3 mean, so that method applied to, and then I give it the data where I'm going to look for this array, and then I give it this little accessor function. So I am going to say from this data, I am going to access the body mass property values. And really what that's doing is getting an array that D3 mean can be applied to. And once we see that syntax, then that'll be repeated throughout many different methods that we'll use for calculating descriptive statistics today. So for example, standard deviation is the same exact syntax. So the standard deviation for body mass is the same exact pattern, but instead we use D3 deviation. If we want to find the median of a column, D3 median, but then otherwise the same. Count, D3 count, otherwise the same. So when we do these activities coming up, we'll see that we follow a pretty familiar pattern, regardless of the different descriptive statistics that we're practicing. One note that I wanted to make is that these basic statistics automatically coerce inputs to numbers, and they ignore invalid values. So if you have undefined nulls or not a numbers, NaNs, this is from D3 maintainer and observable data visualization wizard and very generous sharer of all knowledge related to JavaScript and D3. That if you check out this notebook, there's more information on how these probably work. But these are nice because they do ignore invalid values that you'll oftentimes see in real world data, where it's actually oftentimes has missing values. So to clarify this, if I am looking at this mass array here, notice that you can also just put, if it's a single array, then you can just add that array directly within these different D3 methods. And here, notice that I have 12 and 8. 8 actually input as a string here, but when I use mean, it coerces that 8 to a number if it's possible, and any invalid values are just ignored, which is why I get this output for 10 here. And when I use count, and this is a useful one, when I use count here, it also will ignore invalid values in the count it returns. So here, the count of mass ignores this NaN and this null value, which differs from the length method that we used previously with arrays, which will return everything regardless of the value. All right. So let's go ahead and just hop right in. Let's just start doing some of these summary statistics. So I'll hop back over to the notebook, and if you're following along, you can scroll down to activity 2. And we're going to calculate a few common descriptive statistics. So the first one is, let's find the minimum Coleman length in penguin data. So here, I'm just going to use d3.min. The first piece I'm going to give it is the data. Where to find this is penguin data. And then I'm going to create this little accessor function that tells it what property I'm actually going to find the minimum value for. So here, I'm going to say, create this little accessor function, and I'm going to do d colon length millimeters. So that's going to access all of the values in the colon length property, and then it's going to find the minimum of those values. Again, I'll press shift return to run this code and find 32.1 is the minimum value across all penguins and all islands is how this D3 minimum is going to get us a minimum value. All right, it doesn't always return a single value. Some of these methods return like an array of values. For example, D3 range is going to return an array where the first element of that array is the minimum value, and the second value in the array, the second element, is the maximum value. So for that, we will use D3 extent. But then otherwise, the syntax is exactly the same here. So I can use penguin data and then use, again, an accessor function to say, find the extent of all of the values in the colon length millimeters property. And you can see here that we get an array back. This can be really nice, and we'll see examples of this in tomorrow's session. This can be really nice, for example, for creating programmatically the bounds of a slider input based on the actual data instead of like manually typing in endpoints. So we can base things on the actual data values. All right, so we'll keep moving, and then after I get through these, I'll take a look at the questions. Mean is the one that I showed, so if we want to find the mean of all body masses in the penguin data, then I could use D3 mean, again, say look in penguin data for find the mean of all values in the body mass grams property. That gets me the mean value. And I also show an alternative here. And this is just showing that you can just give any of these just a straight array of the values. For example, here, if instead of giving it these two different pieces, the data and then an accessor function to access the properties values, I can just give it the array of body mass values directly. Like if I use map to iterate over everything in penguin data and access body mass in grams, then D3 mean here is acting on that returned array. So you can provide it with just an array of values too. Okay, so some other examples, and at this point, hopefully you're feeling like, oh, okay, this is feeling like predictable syntax, which is great. So really it comes down to oftentimes if you're using some of these methods from D3 is like looking at the documentation and just seeing what the names are. Because for example, some of these are really predictable and the same as in other languages like mean and median. But some of them are different. Like here's one. If you've been working in R, then you're probably used to using SD for standard deviation. But this D3 method uses D3.deviation. But then otherwise, again, penguin data, and then just give it the accessor function for the property that you want to find the standard deviation for. All right. And we'll do one more, but we're like just cranking through these, right? Like once you see the pattern, then you can apply any of these methods to get descriptive statistics for an entire property of your data. One more counts, just because we'll also be returning to this later. I'll use D3 count to return the total number of observations of valid values in the flipper length column. So here, again, from penguin data, I'm going to say, tell me how many valid values there are in the flipper length millimeter property or column. And it says there are 342. So this also, in this full data set, there are 344 total penguins here. And so this tells me like, oh, there's 2 penguins that didn't have a valid flipper length recorded. And if you look back through the original data, you'll see that there's 2 missing values there. All right. So I'm going to check the questions and see if anything came up during activity 2. Okay, so questions about the table. Absolutely. This is a cool one. So the way that you can create a table is if you have any data stored within your observable notebook. So again, here, Penguins is built into Observable. I created a copy of it called Penguin Data. But if you have data stored, then you can use one of our specialty cells to create a data table cell. And the way that you add that is you can click anywhere in your notebook on one of these insert cell plus signs, and they're searchable. So if you start typing data table, then you can see there's multiple options for tables. You can use standard JavaScript table. The data table adds a little bit more functionality. So you can then, it'll insert this specialty cell for you, and then you can select what data source you actually want to choose from. So again, and those have to be named sources within your data. And once you select it, then it'll automatically show up not only this nice rectangular view of the data, but this also is a way that you can do some essential wrangling and sorting. So you see these buttons down here? Like I can use these to filter, select columns, sort my data, slice rows. You can also use it using these headers up top to do either some like temporary filtering. Like this is really nice. I'll just talk about data table cell for a bit. It's really cool. So up here, this is interactive out of the box. So if I click on Adeli's up here, it's pronounced Adeli's, like going to a deli to get a sandwich. So if I click on Adeli's here, then it'll automatically adjust what's highlighted across the other variables to show me how just that group compares to all of the groups combined, which is awesome. So like without doing any additional visualization, I can see that these Adelis happen to usually have relatively short bill length, which they do. If you look at a picture of an Adeli, they have pretty short and broad bills. And they're also pretty small. So compared to all 3 of these combined, they also have shorter flipper lengths and generally lower body masses. So this is cool. Like the data table cell is really nice, not just to get an initial glimpse of your data, but also to do some interactive exploration, which I think can be really useful to start seeing patterns right out of the box. Okay, so I will look at the questions. Okay, Alejandro, good question. So the data table cell specifically, which I think is what you're asking about, but let me know if I'm wrong. The data table cell, yes, is a specialty cell specific to observable. We have a couple of other specialty cell types where that's also true. So for example, there's not currently a way, like if you're working in a Quarto document to create a data table cell out of the box. Yeah, good question. Okay. All right, so I'm gonna switch back to, okay, and yeah, thanks whoever answered. If you D3, will work anywhere. But specifically the data table cell is an observable specialty cell. Yeah, thanks. All right, so I'm gonna head back to the slides, and now let's extend what we've been learning about descriptive statistics to be able to do it by different groups. Because you can imagine, like in the examples that I've just done here, when I was finding like the mean of body mass, That's for all of the penguins in this data set. But oftentimes when you're working with data, you would want to find a summary statistic by group. So maybe here I would want to find the mean body mass by penguin species, for example. So here, let's go ahead and learn next about groups and rollups. And these are really useful when you actually do want to identify and work with different groups that exist within your data. So first, we're going to learn about D3 group. The job of D3 group is to group values by key. And it works using the same syntax as we've been using previously for these other summary statistics. So here, if I use, for example, D3.group on penguins data using the species key, then what it's doing is identifying the different unique levels within that species property and saying then each of those belong to the same group if they're, like in this case, the same species. And what's returned when you use D3 group is a map, which is a data structure that we haven't seen before. And it's different from which, like the language here can be a little bit tricky because we've been using the array.map method, and that's what allows us to iterate over different elements in an array and do something with them and return something back. This is different. This is a capital M noun map data structure. So what is that? And you can see it looks a little bit different than the objects that we've been working with, but there's some similarities. And they are similar in some ways and different in some ways. So a map, like an object, contains key value pairs. Like in this map, that is the outcome of that group that I just showed. In this example, we see that each of the keys are the different species that existed in that species column or species properties that we were grouping by. And then the value is an array containing the information associated with each of those groups. So the other variables associated with that group. How does a map differ from an object? First, keys for a map can be anything, like they could be a function or an object, whereas keys of an object must be strings or symbols. Maps are iterable and they remember the element insertion order, which an object doesn't always do that. And there are some helpful properties that give you information about the map. For example, the size property of a map gives you the number of key value pairs, where there's not sort of an analogous method for objects. So they differ in some ways, but they are similar in the way that they contain key value pairs that store information for us. All right. So now I'm going to go back to, check in the questions. Cool. Okay, so if you have a map, then this is like really, this always feels like a big win for me for some reason. I'm not sure why, but you can get pieces from a map just using get, which every time I do it, I'm like, is it that simple? Is that simple? Which is really great. So let's say, for example, that I have created a map using D3 group of penguin data by species. Then the output is this map, and I can access pieces of that by key. So here I've stored this map as group species. And if I just want to get an array of objects only for the adeles, then I can just give it the name of that map, .get, and then give it the key. So in this case, the key is adele. And what that returns is an array of objects. So that actually creates like a really nice way that you can access different pieces without like filtering every single time for each individual species, for example. Here there's only 3, so maybe it wouldn't be that big of a deal. But it's really nice to actually access different groups of data and return it with get as an array of objects, which is the way that we've been working with data already. So they're really cool. So let's go ahead and move on to activity 3. So for activity 3, we can scroll down in our notebook. We are going to recreate the example that we just saw. So I'm going to start by saying, and if you see an error in the cell below, that's okay. It's because we haven't defined group species yet, so it doesn't know what to do with it. But here, I'm going to say, I'm going to create a new map called group species. I'm going to create that map using d3.group. The first thing I'm going to give it is the data that I'm going to be using to create those groups from. And the next thing that I'm going to give it is this little accessor function using the arrow function, where this is specifically accessing values in the species property from penguin data. And once I run that, then you can see that this map shows up. And you can see if you expand that, and as a reminder, once you've created something in an observable notebook, it shows up right above the cell that you were just typing your code in, and you can expand those outcomes by clicking this little arrow just to the left of it. So here I can see that what this map contains is actually 3 key value pairs. The first key is a deli, and I have an array that contains an object for each of the 152 Adelie penguins in this data set. Second key is chin strap. So I have the 68 objects for chin straps, and the third is Gen 2. So I have 124 objects for each of the Gen 2 penguins. So what if I wanted to then just get the Adelies? Then I can use get here. So here, if I then type in, okay, starting from group species, that's my map. That's the map that I just created. I can use .get and then give it the name of the key that I want to access. So here, I'll do Adelie. And then you can see what's returned, and this is really nice. What you can return is an array of objects that only includes observations for the Adelie penguins. So here, now I can see that if I scroll through these 152 objects, the only species that would exist here is for the Adelie penguins. So it can be really nice. But you might ask, well, like, can I have different levels of grouping? So could I group by species and island? And yes, you can. So it's really nice. The way that this is going to work, and we didn't see an example of this in the slide, but we're just going to keep adding in our D3 group method. We're just going to keep adding separated by commas accessor functions to tell it what different properties we want to create groups by. So let's try it here in this one that says group penguin data by species and island. So here I'm going to say D3 group again, and I'm going to store this so that the example later on works. It's expecting an camel case name, group species island. So I'll give it a name. And then I'm going to say use D3 group to create a map based on data in penguin data. And the variables that I'm going to group by, this is where I'm going to provide my different accessor functions written using the arrow function operator. So here, the first one, I'm going to say first group by species. And then if I did this, we would get the same thing as the example we just did above. But second, I'm going to say, and also group by island. And then what this gets is this gets a map where you can see now we have this little nesting structure, which might look overwhelming at first, but I think that using get actually clarifies how nice this can be, because I can just continue to like chain through get methods until I have the piece that I want. So let's say, like this next example says, let's say that I want to get observations for Adelie penguins on Dream Island. Then I would say, okay, from this outermost, like if I'm going inwards in an onion, first I'm going to access the Adelies, and then I'm going to get from that inner map for Adelie, I'm going to get just the observations for Dream Island. So let's go ahead. Yes, Angie, let's put maps and maps and maps. Okay, so let's go ahead and get Adelie penguins just on Dream Island. So I'm going to start with this group species island, and then I'm going to say get from that the array of objects or the map for Adelies. And if I just run that again, then what this returns is this innermost map for only Adelie penguins. But then I have a map, so I can still continue to use get to just get whatever objects for the key that I want. So here I'm going to say then get just an array of objects for Dream Island. And then what I have, if I expand this array, is an array of objects just for Adelie penguins on Dream Island, which I think is like a really cool, like a really nice way to create subsets, and a really quick way to explore and create subsets. So we can take a look at that, but you can see that this tells me that there are 56 penguins that satisfied both their Adelies and they were observed on Dream Island in this data set, and that gives me a quick way to access them. But if I wanted to change this, then like if I said like, actually, I want to return an array of objects for all the Adelies on Bisco Island, then I could just update my get key to Bisco, and then I can see that now this is a subset for Adelies on Bisco. So this combination of grouping and get is really nice. And there's a lot of other uses for maps, like calling values by name in other places. So you could join information based on those keys. But this is one that I think is also pretty nice. All right, so I'm going to check to see if there's questions. Great question. Okay, so can I use Arcaro to get summary statistics? Absolutely. And this is something that actually, I'm going to show it now. Can you do this with Arcaro? Yes. So I'm going to actually hide this just so it's not over the actual code that I'm showing, but great question. I do show a little bit later on in the slides how you can do this using Arcaro verbs. And this might look familiar, especially if you've been working with dplyr in R or other dplyr-ish tools in other languages. You can see that you can do like group bys and then rollups, which would be the equivalent of like a group by summarize in R, for example. Okay, if you want to create multiple subsets, so let me check another question. Great questions, everybody. Hi, Maddie. Okay, if you want to create multiple subsets from one array, could you assign this to its own object? So yeah, you could store each of these different subsets that you created just using get. You could also automate that, like iterate through them to store different subsets. But yeah, you can, if you wanted to create multiple subsets, you can assign any of those to its own name that's bound to that subset and then use that later on. Absolutely. All right. Okay, so I'm going to hop back to the slide. So we just finished talking about grouping and get. So we've covered a lot already, like recap and descriptive statistics and D3 group and maps and get, which is we are just rolling along. Now, what if we want to find some summary statistics by group? Because what we've done so far is we have actually just found a descriptive statistic for like all values of a property. But we haven't said like, actually, I want to have a different summary statistic for each group and done that automatically. Now, there are ways you could get around it, right? You could create these different subsets and then apply that mean to these different subsets, but that's kind of tedious. That it seems like we should be able to roll these into one, which is what we're going to learn now. And we're going to do that in JavaScript using D3 rollup and a friend that we'll see that just gives you a slightly different output. Okay, but what's the general pattern to a rollup? A rollup is a way that you can reduce multiple values by group into a single summary statistic based on the key that you specify. So here, to talk through this code, I'm using D3 Rollup. The first piece that we give it is the data that we're going to find this summary statistic by group for. Then we give it a reducer function. And this reducer function, we're going to talk through in a minute. We're going to break this down a little bit. But this is saying I want to calculate the mean for each element I want to calculate the mean of the body mass property. And then this last piece tells us the key that we're going to create groups by. So in this case, this is saying like by species. So to break that up a little bit, how do we read this code? Again, we say from the penguin data. So from the penguin data, I want to return the mean of the body mass property. So that's what this entire thing does, is like, given this penguin data as a starting point, remember D3 is expecting the data to be the first piece that you give it. So that's like, okay, if this is penguin data, that's what it's expecting. Then I first give it that penguin data here as the first element in D3 mean, and then I tell it what property I want to find the mean for. So that's reducing the mean, taking multiple values and finding a single mean value. But then this last piece is actually saying what is the key that we want to identify different groups within, and then calculate the summary statistics within those groups. So that's what this code is doing. And the output of D3 Rollup is also a map. So here, if I do D3 Rollup to say, hey, I want to calculate the mean of body mass for the penguins data by species, then the output will then have for each of the unique levels within species, that will have the key is those different levels here, Adelie, Chinstrap, and Gen 2. And then the value is that summary statistic. So this is the mean body mass for each of those species. Now, you can have there are other options. So this returns a map, but there are different ways to do rollup. So there's different options. And I'm just going to show one today, which is flat rollup, which looks exactly the same as the rollup code, except you can see that the function it uses is flat rollup. But what it returns is different. So instead of returning a map, it actually returns an array of arrays. And we'll see in an example that we can also then convert this back to an array of objects, which is how we've been working on figuring out. I am loving these comments. V is for victory. Yeah, I'm gonna say that from now on. That's why we use V. Okay. Okay, and yes, just to not lead anybody astray, generally used to mean values, that V that we use as a parameter in the arrow functions. Thank you. So let's go ahead and try it. Let's try using this rollup to go ahead and find summary statistics by group. This is, again, just an aside, we're not doing this in our Caro today, but you can absolutely do the equivalent of like a group by summarize in our Caro using group by and rollup. So you can do the same things there. Okay, let's go ahead and jump into our notebook, and we are going to be there for the rest of the day. These sessions just totally fly by. Okay, so for activity 4, so you can go ahead and scroll down to activity 4. I'm going to talk through this code, and then we'll do a couple of examples. So here, I'm going to start by saying, hey, I am going to find summary statistics by group. That's what D3 Rollup is going to do for me. And then I'm going to have the first piece that I give it be the data. So that's the first thing that it's expecting is penguin data. The next is going to be this reducer function. So this reducer function, I'm going to say, okay, starting with that penguin data, I'm going to find the mean. And again, D3 mean, right, is expecting these pieces, is expecting first the data, which here is just V, this bigger array that it's accessing. And then what is the property that I want you to calculate the mean for? So here, I'm going to say I want to calculate the mean for body mass in grams. But the last thing that this needs, now I've given it two pieces. I've told it the data that I want it to use to do this roll up. I've told it the reducer that I want to apply, so finding the mean of body mass. But the last thing that rollup needs is it needs to know what property you want to split this up by to calculate the different summary statistics by group. So here, that's what I'm going to give it next is, again, a little accessor function where I'm just saying I want you to have this key where groups are created be dependent on the different unique levels that exist in species. And if you run that, again, shift return or pressing that blue arrow button, then you can see that this returns a map. We can again use get here. So like if I wanted just the Adeli value, I could give this a name and then just chain into .get Adeli, and that would give me just the Adeli value back. But this returns this map that has for each species of penguin, it has the mean body mass value. All right. Now we might ask the question, just like we did with groups, we might ask the question, well, what if I want to group by more than one thing? Like here, what if I want to group by penguin species and sex so that I could get the mean flipper length by species, but also broken up by if it's male or female or unrecorded penguin sex. So let's go ahead and do that. And the way that we do that is just like we did with D3 group, where we add any additional grouping keys just separated by the comma to the end as additional elements within that D3 rollup as additional pieces. So here, I'm going to do D3 rollup. I say, first, look in penguin data. I'm going to find the mean flipper length. You can write this out if you want to. That's great. I'm going to copy this code that I had written to find the mean of body mass and then switch this out for flipper length millimeters. So that's my reducer function, is finding the mean of the flipper length property. But then instead of giving it one key that I want to actually group things by, I'm going to give it two keys. And these are just going to be separated by commas. I'm going to say the first grouping that I want to do is by species. And the second grouping that I want to do is by sex. And then what's returned, and you could do this for as many different grouping variables as you wanted to, or grouping keys. Then what I get again is this map that has maps within it. But we could access any piece of this, whether for Adelis, get the map back for Adelis, or any piece of that using get. All right. Okay, I see a question in here. Okay, is flat rollup like dropping groups in dplyer's group by, or is that not similar? I don't, and again, yeah, let me know in the chat if I'm answering this incorrectly. I don't think that it's doing the same thing as like ungroup would be doing. So it's not saying like don't recognize these groups anymore. Is it, I'm trying to think of what the equivalent of flat rollup would be versus, I guess like my reaction is like flat rollup is pretty close to what you get if you do use a group by summarize, like that it's already broken up into kind of tidy structure with your different grouping variables. So I think of flat rollup as pretty close to what you would get if you did use group by in combination with summarize. So I think that's the answer that I'll give for now. But I'm curious, yeah, if other folks have ideas in the chat around dropping groups, then I'd be curious to read them. Okay. All right, so let's look at flat rollup. So far we see like these examples, we can see return a map, and then this returns maps within a map for these different grouping keys that we've specified. We can access them with get. get, G-E-T, get. But alternatively, we can create an array of arrays as the output using flat rollup. Before we jump into this, because I'm expecting a question to be like, wait, an array of arrays, how do I get back to an array of objects? And I want to just preface that a little bit by showing an example. If we have an array of arrays like we have here, so there's just this little example that's 2 arrays within one larger array. So this outside array has 2 elements, and they are each an array that has 2 elements within those. Then if I want to get an array of objects back from that instead, the way that I can do that is using map and say, remember, that's iterating over each element in an array. And this is saying like, okay, if I'm expecting an input that is an array of 2 elements, like this first one has 2 elements, 1 and 2, if I'm expecting that input to be an array of 2 elements, then I would like you to return, through the process of doing this map, an object that stores those 2 elements as the values. But what this is also going to do is it will automatically assign these parameter names that we created as the key names. So this is kind of like doing multiple things. So it's transferring each of those values into the values of an object instead of array elements, but is also making the keys for each of those properties in the new objects set to these parameter names that we've given it. Which is why then when I expand this, I can see that now instead of an array of arrays, I have an array that has 2 objects in it, and the keys for those objects are those names that we had specified here. So we're going to use that in this next example. All right, I'm going to go ahead for time and click on this show me button, and let's go ahead and we can copy this and then we'll walk through it. So I'm going to click on this, which just is, again, doing the same thing as Rollup. So there's no mystery about like what it's doing for us, but it is giving us a different output. So here I'll copy that code into that cell and run it. What's happening here? Flat Rollup is returning, again, an array of arrays. Like if I comment out this last map step and run this D3 flat rollup, I can see I get an array of arrays. But again, this is just has like my group and then my value. But the next thing that I'm doing here by adding, by just pushing this into this map method, is this is what's converting it to an array of objects where the keys are these property names that I specified. So it can be really nice. So that's a nice way to get from an array of array back to an array of objects using flat rollup, which I think is a nice alternative. All right. One last thing that we'll show in 1 minute. We're going to create a bar chart. I'm going to go ahead and again, just talk through this for the sake of time. But if I copy this code to create a bar chart from the Penguin data, what I want to highlight here, and we'll do more of this in session 4 tomorrow, is that you don't necessarily have to find those summary statistics beforehand and then use those summary statistics like calculated as is in Observable Plot, because you can actually do a lot of finding of descriptive statistics and reducing things right within Observable Plot. So where does that show up here? This is creating a bar plot, but you can see that I've also created this grouping for the X variable. So I'm saying I want to group by the X variable. And once I've done that here, so a group for a categorical variable, we'll also see how we can bin continuous variables. But once I do that, I can give it a reducer that I want to apply by group. So here I am saying this is where I'm finding the mean value for this Y variable, which is body mass. So here it's showing in this chart the mean value for each of the penguin species, which is my grouping x-axis, my grouped x-axis variable. But there's also a bunch of other built-in reducers, and you could build your own reducer. But here, for example, if I change to like median, then my chart is updated using a median reducer. If I change to deviation, then instead my chart is using a standard, is showing standard deviation by group. So there are a lot of ways. So yes, oftentimes we'll want to calculate those values outside of Observable Plot. But keep in mind, and again, we're going to be doing some of this tomorrow, that you can do a lot of this reducing to visualize summary values by groups right within Observable Plot by setting variable or value groupings or binnings, and then saying what the reducer is that you want to apply to all values within each group. All right, so that gets us to time. As a reminder, our next session is tomorrow, same time, 12 p.m. to 1 p.m. We'll keep looking at data grouping and transforms. We'll continue with Observable Plot, and we will have some fun adding interactivity in Observable Plot using inputs. We'll do a little course wrap up and let you know future opportunities. So we will really look forward to seeing you tomorrow for the last session of this course. All right. Thank you, everybody. Remember to find us in the Slack channel with more questions and follow-up.